A mighty river flows, ancient, powerful, unstoppable. But here at Polavaram, humans seek not to conquer it, but to guide its waters, harness its strength, and transform its force into life, energy, and hope. This is the story of one of India's greatest engineering marvels, the Polavaram project. Every monumental structure begins with an idea, and Polavaram's idea is both simple and profound: to harness the Godavari in a way that benefits millions without destroying its natural flow. The project is designed to irrigate vast stretches of farmland, ensuring that crops flourish even in years when rainfall is scarce. It will deliver drinking water to cities and villages, providing a lifeline for communities that have long endured uncertainty. And it will generate hydroelectric power, converting the river's kinetic energy into electricity that lights homes, powers industries, and fuels progress. Equally important, the dam will act as a shield, protecting lives and property from seasonal floods that once swept through villages, fields, and towns with devastating force. Achieving this vision requires meticulous planning, precise calculations, and the coordination of thousands of engineers, technicians, and laborers. The Polavaram project embodies human ambition, guided by knowledge, patience, and respect for one of India's greatest rivers, turning a bold vision into a promise of security and prosperity. Before the dam can rise, the Godavari itself must be persuaded to yield, at least temporarily. To achieve this, engineers construct temporary barriers known as cofferdams, massive walls of rock, soil, and steel, designed to divert the river's force into controlled channels. Across the flowing waters, enormous dump trucks carry tons of stone, while excavators sculpt the landscape with remarkable precision. Slowly, the river retreats, revealing dry land where construction can safely begin. It is a delicate balance. The river is immense, carrying sediment, debris, and enormous pressure. Yet human ingenuity works in harmony with nature to redirect it. Every stone, every mound of earth is carefully placed, monitored, and reinforced. Workers and machines move in coordinated rhythm, day and night, guided by the knowledge that one miscalculation could send water crashing through the site. Through this painstaking process, the first step of construction becomes possible. The cofferdams are not merely barriers, they are symbols of the human ability to negotiate with nature, creating a temporary order in a world defined by powerful, untamed forces. With the river temporarily diverted, the ground beneath Polavaram is exposed, revealing the bedrock that will carry the dam's immense weight. Excavators and bulldozers move methodically, cutting through layers of soil and fractured rock. Drilling machines penetrate deeper, breaking apart stones that have remained untouched for millennia. Every layer removed is carefully measured, tested, and documented, for even the smallest imperfection could compromise the entire structure. Here, human skill and machine power combine to transform raw earth into a foundation capable of withstanding the immense pressures of the river. It is a slow, deliberate process. Every cut, every movement is designed to create a platform not just for a dam, but for a promise. With the foundation secured, the massive task of building the dam itself begins. This is not a single act, but a careful layering of earth and rock, compacted and shaped to withstand the immense forces of the river. Massive excavators place stone and soil, while rollers compress each layer to achieve the exact density required. Every layer is tested, measured, and adjusted, ensuring the stability of the structure as it slowly rises from the riverbed. The scale of human and machine effort is staggering. Trucks, cranes, and bulldozers move ceaselessly, while workers coordinate the placement of materials with precision and care. Each ton of rock contributes to a structure that must endure the pressures of water, time, and nature itself. The dam rises steadily, layer by layer, a visible testament to human patience and engineering skill. It is both art and science, where technique meets endurance and where every movement of Earth contributes to a future where the river's force is guided but never completely restrained. Even a dam must respect the river's power. To manage excess water safely, engineers build a spillway, an enormous controlled outlet that will release water when levels rise too high. It is a structure of precision designed to balance the immense energy of the Godavari with the need for safety downstream. Concrete is poured in massive volumes, shaped into channels capable of guiding thousands of cubic meters of water per second. The gates, engineered to open and close smoothly, allow the river to flow when necessary, preventing catastrophic flooding without sacrificing the dam's integrity. It is a safety measure, a marvel of engineering, and a symbol of respect for the river's power. Before a single watt of electricity is produced, the heart of the hydropower system is born far from the river. The process begins with turbine manufacturing. Giant steel components are cast and forged, then machined with extreme accuracy. Each turbine blade is shaped to guide water smoothly, extracting maximum energy from every second of flow. Even the smallest imperfection can reduce efficiency or cause vibration, so tolerances are measured in fractions of a millimeter. Next comes the generator, the system's electrical core. Copper windings are carefully insulated and layered inside massive steel rotors and stators. These components must handle high rotational speeds, intense magnetic fields, and continuous load without failure. Once manufactured, these colossal components are transported to the dam site using specialized trailers, cranes, and lifting systems. Some parts weigh hundreds of tons, requiring meticulous planning just to move them safely. Inside the powerhouse, assembly begins. Turbines are lowered into position with millimeter-level precision, aligned perfectly with shafts, bearings, and generators. Engineers perform alignment checks again and again. Sensors, control panels, and automation systems are installed, allowing operators to monitor flow, speed, temperature, and output in real time. Finally, water is introduced. As gates open, the turbine begins to turn. What was once silent steel now moves with purpose. The generator spins, electricity flows, and the hydropower plant comes alive. From the heart of the dam, a network of irrigation canals stretches outward, like arteries carrying life-giving water to parched lands. Fields that once waited anxiously for the monsoon now receive water with precision, transforming dry soil into fertile farmland. The canals are meticulously engineered to maintain a steady flow, using gravity, gates, and channels to distribute water over vast distances. Villages and farms that struggled for centuries now have a reliable source of sustenance. It is here that the dam's purpose becomes tangible, a living network that converts stored water into productivity, growth, and hope. Every field that flourishes, every crop that thrives, is a direct result of the river's force harnessed carefully and wisely. For generations, the Godavari has brought both life and destruction. Seasonal floods once swept through villages, destroying homes and fields in their path. The dam changes that. Water is managed with precision, allowing humans to coexist safely with a force that was once unpredictable. Floods no longer strike without warning. Villages are shielded, crops are saved, and lives are preserved. Here, engineering becomes not only a technical achievement, but a humanitarian act, a promise that the river's power can be guided without harm.